So our reason being for this one is rectangles are parallelograms. So rectangles are parallelograms. All right, so now because of the fact that we know that those are parallel, because we know these are parallel, we know angle BEG, so this angle right here, is going to be congruent to angle ECD. Now, how we know that? This is a transversal being cut by two parallel lines. So, because these are parallel, these are what's known as corresponding angles. So that's from this part right here. I know the angle that BE makes with GE must be the same as the angle that EC makes with AC, since those two segments are parallel. So angle BEG is congruent to angle ECD. So we come down here, number 5, angle BEG is congruent to angle ECD, corresponding angles. All right. She also said that she can make the same argument for angle GBE and angle DEC. So she is correct. Those are also congruent. So looking back up here, GBE, it's that angle right there, and DEC, this angle right here. Those are also going to be congruent because they're corresponding. They're in the same relative position. So angle GBE, and I know this is really hard to read. Hopefully you're doing okay. Angle DEC. Once again, corresponding angles. I'm not going to write it a second time, okay? All right, and then the last part. So we've shown, so what we're trying to prove is that triangle BGE is congruent to triangle EDC. So do we have 3 things that are congruent between the two? Yes, we've got 2 angles and a side. So anytime we're trying to prove that triangles are congruent, we have to have 3 things. We have to be able to show that there are 3 parts of the triangle that are congruent to one another in order to do that. So we have angle, side, angle, because we have these angles here, this side, and then the angle down at the bottom. So now we are on our proof statement. So the last statement in your proof, I'm going to skip a space so you can actually read it, is always going to be your proof statements. This is always the last line of your proof under statements. So triangle BGE is congruent to triangle EDC, and we said it's by angle, side, angle. So when you're doing proofs, you have some stuff that's already given to you. Like I said, our givens were right here. Those are the first 2 things you write down. Your reason for those is always given. So your first reasons in a proof should always be just given. So you know the givens, you're given the statements for the first, for whatever you're given, and then you know the last line of the proof is what the proof statement is. So you have a few parts of your proof already given to you before you even begin and start working through them. Okay? We'll work more on proofs as we go. This was just a precursor. Some of them are 7 steps long, some are 4 steps, some could even be 3 steps. It just depends on how much information you're given and what you're trying to prove. So, all right. Our last section, transformations. This is very similar to what we did just the other day. Perform the following transformations on triangle ABC. Use a straight edge, connect the corresponding points with a line segment. Answer the question. So we want to reflect triangle ABC over line LK and label our new image triangle A prime, B prime, C prime. So there is our triangle. We're reflecting it over LK. So if we look, here's our C. We go over and up and over. So it's going to go right there. It's going to be our new C point. B is going to be up here. A is going to be, one, two, three, four, right here. So here is our new triangle. Obviously, you guys are going to do a lot better at drawing the sides than I'm doing right now, but you get the idea. So like I said, this was our B prime. Oops, that was A prime. A prime and C prime. So what do you notice about the line segments A to A prime, B to B prime, C to C prime? So if we draw these line segments in, I know mine aren't the greatest because mine's very off, but what we should notice about those is that they're all what to our line of reflection? They are perpendicular. So anytime we reflect over a line, the lines that connect the original point to the new point, that line is always going to be perpendicular to the line of reflection. So compare line segments A, B, B, C, and CA to A prime, B prime, B prime, C prime, C prime, A prime. What's the same and what's different about these segments? So what's the same is they're congruent. Remember, when we're doing transformations, it's a rigid transformation. They don't change length. So they are congruent. But what changed? So if we look at the directionality of these sides. Look how they've changed. They're not going the same slopes anymore. The slopes have changed with this reflection. So the slopes will change, but different slopes. So this section is going to be a lot about looking at their slopes and looking at parallel, perpendicular, congruent, intersecting, all those sorts of things, okay? All right. You guys will finish out the rest of those. So you're doing a translation next, and then you'll do another translation with a reflection and compare each of those, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day.